So, hello friends. In this video, we are going to know what is divergence. I'm going to tell you the deep physical intuition of divergence. What is divergence? Why this formula of divergence? So, first I will answer the question, what is divergence? So, divergence is a mathematical operation and it is applied to a vector field, okay? And that tells that the point of a vector field or that area of a vector field has the nature of sourceness or sinkness. Now, what that means? That essentially means is like see here. Here the vector field is right. This arrow is representing my vector field, and here you can consider a area of vector field. Okay, and here you can see the arrows have increased. So the vector field magnitude of this area is less than this area. So you can say that this area is acting as a source to this vector field. So because here the vector field is less and here the vector field is more in magnitude. So how this can happen? It only happen if this area is supplying or adding vector field to current vector field present here. Okay. So that's why here divergence is greater than zero, and this is called the sourceness nature of vector field. And like you can see, positive divergence indicates source when there are more flow going out than coming in. That's why the area is considered to be a source. Now let's talk about the negative divergence. So it will be the exact opposite of it when there are more flow coming in than going out. See, here the vector field having the magnitude less, sorry, more. Here the vector field having magnitude less. So what happened? Here the magnitude is more and here the magnitude is less. So, so in that scenario, we can say that this area is sucking in the vector field. This is eating the vector field. So we can say that this is acting like a sink to the vector field, right? So here the divergence is less than zero. Now let's come to the part where divergence is equal to zero. Means there is no change in the vector field in that area. Here the vector field has same length. Here the vector field also has same length. No change in that area. So neither it is acting as sink nor it is acting as source. Neither diverges nor converges. So zero divergence. Now let's come to the. So I assume you have understood what is divergence. Why divergence? What the divergence is just calculating how much vector field it is telling us the behavior of vector field. Either vector field is acting as a source at that point or sink at that point. Okay, and there can be positive divergence, there can be negative divergence, there can be zero divergence. So divergence is basically telling the, the nature of area in that vector field. So how can you tell the nature of area in that vector field? So basically what we will do, if the vector field, if the length of vector is increasing, magnitude of vector is increasing across the length of dx. So how will you determine how much it is increased? You will simply take the partial derivative of it, like del f upon del x, and multiply the length. Okay. So and similarly you will do with two other directions. That's why the total change in the vector field in this volume can be calculated by if we multiply this quantity to the total volume, right? That's why the divergence is the sum of all changes in change in x, change in y, change in z. That's why divergence formula is this. How much the vector field has changed in x, how much vector field has changed in y, how much vector field has changed in z. It is accounting for each part. That's why the formula is this for a three-dimensional vector field. So now I will summarize the video. What is divergence? Divergence is a mathematical operation applied to a vector field, and it tells us the nature of that area in the vector field, whether that area is acting as a source or sink. If that area is acting as a source, then it will have positive divergence. If that area is acting as sink, then it will have negative divergence. If that area is doing nothing to vector field, it will have zero divergence. And the formula of divergence is del f upon del x plus del f upon del y plus del f upon del z. It is indicating the total change in the vector field in that area. If we multiply this quantity to the volume, we will get the total change in the vector field in that area, right? That's why the formula of divergence is this. So, so that's it for the video. Thank you guys.